Hello, it's Keith here, and this is lesson 80 of the platform-specific series of my Z80 assembly programming tutorials. We're back on the MSX again, and we're back doing Mintile again, but this time we're on the MSX2, as you can see by all of these colours. So we're actually working in a true bitmap mode this time. Of course, because of the way the MSX2 works, we have to transfer all of our data, in this case our tile data, to the VDP, and then we have to transfer it around the screen, and we're only using a single buffer here in this case. Now, how are we actually doing our graphical data? Well, if I move over to this window here, this is actually the debugger screen, and this is showing the contents of the video memory that I captured earlier. So basically this is the first 256 lines of video memory here, and you can see we've got our screen here. This is the actual screen at the point when I captured this. If we go to bank 1 here, you can see what we've got is we've actually got the normal pattern data of our tiles here. So each 8x8 pixel pattern here is actually in video memory here. So there's 32 per line there. Now if we go to page 2 though, you will see we have some of our patterns a second time, but this time they've been X-flipped, and so that's how we're doing our X-flip effect. We're actually using a second set of patterns, 256 lines on from the first set. So that's what we've done, and we've actually created some code here to calculate the flipped equivalent of the patterns and transfer them into VRAM. So that's what we're going to be looking at today. Let's go over to our source code. Let's take a look at it. Okay, so this is the version we're looking at today, MSX2 Mintile here. So we've got all of our code here, but of course it works very differently from the original MSX1 version. Now at the start of our code here, we're basically setting up some template VDP commands here. These are ones that I've actually used in the past. So this is we're going to tweak settings of them, so we have to transfer them to VRAM. So we've got the template versions here, and we are transferring them to the VRAM destination here, which is in memory. We're assuming that our code here could be running from a cartridge. MSX2 is variable, you know, most MSX2s have 64K RAM, some of them are disk based, but by assuming we could be running from cartridge, we have the most potential for our code later on. Okay. So basically we've got a program called Sendtiles here. This is going to transfer the unflipped source data, bitmap test sprite here in this case. The number of tiles here is 16, and we are going to load to position X position 0, so at the far left, and the Y position is being specified by test sprite. Well, what is test sprite? Well, in the case of this code, it's actually a Y position, so we're loading that to VRAM Y position 256. Test Chibico, we're loading to VRAM Y position 256 plus 8, so we're allocating 8 lines, 32 tiles, because there's 32 tiles per line, to our test sprite, which is actually our pattern data for our background. So here we are transferring the test tiles for our background scrolling tilemap, and we don't need to XFlip those. However, our Chibico character, we do need to XFlip because we might want to flip that around. So the first time we're using send tiles, and Chibico is 40 tiles, but then the second time we're using send tiles reverse, and we are specifying a different Y position. Test Chibico is our Y position in both cases, but we're adding 256 when we send the reverse tiles. Now in all cases IX is actually 0, that's the X position, it's only the Y position we're changing here, and the number of tiles. So let's take a look at send tiles and see what it actually does. Now if you've seen my previous bitmap examples on the MSX2, maybe things will look a little bit familiar, hopefully they will. So here is the send tiles routine, and we are going to use a HMMC command to transfer the data. Now these are my template commands that I've used in the past. We're not going to look at the exact code that does these. I've covered it in my previous examples, but basically this is a sort of template version of the code to transfer data from the Z80 to the VDP, and so this will automate some of the work for us of initializing the command and sending it. So basically what we're going to do, when we run this command, we actually need to load the first byte of data from our source bitmap pattern. So we're loading that into the accumulator here. That's the first byte processed, and what we're doing here is we are specifying the width and height in HL and DE here, and then we are running this command, which is going to basically initialize us to transfer the 8x8 pixels of data to the VRAM and off-screen area in this case. So we're initializing the data. Then we are specifying, once we've done that, we are going to transfer all of the other data. Now there's 8x8, but it's 4 bytes across and 8 lines down. That's 32 byte total. However, we've already transferred 1, so we're subtracting 1 here. And then what we're doing here is we are sending all of the remaining bytes of our pattern data to VRAM here. So that is transferring all of them. Now this is just for a single pattern here. This is just sending a single pattern. So once we've done one tile, we're going to move across. We're moving IX across the VRAM by 8 pixels here. Now, however, if we have got to the end of our screen here, basically if we've gone to pixel 256 at the find of the screen, we can't store any more tiles on this line, so we're going to move to the next line, and that's why here we are basically adding BC, which still contains 8, to IY here and resetting IX back to 0. So we're effectively going across the screen, getting to the end of the screen, moving down a line, and then going back to position 0 here. A bit like a carriage return really, so that's what we're doing there. So that's allowing us to transfer any number of tiles, even if we go over a full line, which we do with the Chibico character. So that's what we're doing there. And then once we've done that, basically, we are decreasing our BC count here. We backed it up into the stack here when we executed, but now we are decreasing our count of tiles. Once we get to 0, we return, but until then, we keep sending those tiles. Now we have the alternate version, send tiles reverse, which is programmed to work in basically the same way, taking the same source parameters at least. Now we need to send the bitmap data in reverse order. We need to send the bytes in reverse order, and we need to flip the 2 pixels in each of those bytes. Now this code is hard coded to work for an 8x8 pattern, so we need to move to the 3rd byte along the last byte in the line of the pattern. So we're inking HL, the source bitmap data, 3 times to get to the end. We're loading the byte in, and we're then basically shifting 4 bits, one of the 2 pixels within the byte, and we're basically swapping them over, effectively flipping the pixels there. So that's what we're doing there for the first byte, the one that we had to load in here before we ran the command to initialize. Again, we have to load the accumulator with the first byte, and we're then initializing the 8x8 area here. And then basically we are going to send the remaining data. Now last time we specified the byte count here, but this time it's a little bit more complicated because we're actually flipping the bitmap data here. So we've got 3 bytes per line, 8 lines here. And what we're doing here is we're loading a byte in from the source bitmap, and again flipping the 2 pixels within that byte, and we're then sending them to the VDP, repeating until we've done the entire line.8 we have done an entire line, we need to then skip over the 4 bytes we just sent, and then we need to move to the end of the next byte because we're working backwards in memory, in our source memory here. So we're decreasing HL each time, so we are skipping back over the line we've just sent and then moving to the end of the next line here by adding 8 here. And then what we're doing here is we are basically just repeating until we've done all 8 of our lines here. And once we've done that, we've got basically the same code. We're moving across the VRAM by 8 pixels here. We are then basically checking and seeing if we're at the end of the line. If we are zeroing, moving back to the start of the, and we're moving down 8 lines to send the next strip of patterns there, and we're just repeating. So that's how we're actually sending our pattern data, and we're flipping our pattern data, and that's half of the job of drawing our characters and our tilemap to the screen. Now Mintile always works in strips, so when we're drawing the tilemap we draw a series of strips for the entire background. When we're drawing a little sprite, it's actually a miniature tilemap and a set of miniature strips. So we have a command called do strip, and that will draw a single strip to the screen. Here it is. Now this works in tiles. So we've got a tile map and we're going to draw it to the screen. Now the first thing we're doing here is we have an X and Y position in H and L. Now this is a bit irregular because in most cases it's actually a VRAM destination, but because this system works in pixels, we're calculating the pixel address from the logical units. One logical unit's a pair of pixels, so we're multiplying the X and the Y position by 2 here to get the pixel position here. Okay, and so what we're doing here is we're loading those pixel destinations into the template HMMM command. HMMM is a fast copy command, so that's going to be quicker. And so what we're doing here is we're loading the tile number that we want to show to the screen. Now if it's a 0, we're going to skip over. In the cache for the tile map, that is a tile that hasn't changed since last time, or in the sprite data, that is an empty part of the sprite. Now, if we are working in sprites, we don't want to change anything, but if we're working with the cache, we want to 0 that after we've drawn it. So we've got this tile clear option here, and we are going to maybe 0 the value in the tile map, depending on whether that's set or not. Now, that would be self-modifying code on other systems, but here we're working from ROM potentially, so we're not doing things like that. So now we've got a tile number from 0 to 255, but we need to convert that to an X and Y position. Now there are 32 tiles on each of our lines. So basically, if we take the bottom, a few bits here, value 0 to 31 here, and effectively multiply by 8, that is our X position here for our source tile. If we then take our top 3 bits here and effectively multiply those by 8 again, we've then got the Y position, and all we do here is we add the offset for our VRAM start of the pattern data. Now that would be something like that would either be the test Sprite address here for the pattern data or the test chibi code data for the Sprite. So that's the kind of data we would be adding there in D&D here, just depending on the Sprite we're drawing. And we're specifying the source Y address here and the source address here. And these are used by the command we will run in just a moment. So we've now got our source address. We're always going to be transferring 8 by 8. So that's hard coded in the template of this command here. And we're waiting for the VDP to be ready. It might be still drawing a previous tile possibly. And then we are running our fast transfer command here. So that is going to transfer our character tile to the screen or our background if the background's changed. So that's what's happening there. Now once we've done that, we're moving the H part of the H and L XY position, adding 8, moving to the next position for the next tile, and then we are repeating here until we've done the entire strip. And this would be run consecutively to draw an entire screen if that's what's required. So as I say, this just does a single strip. Now that's the regular version. We have the alternate flipped version. Now this works in the opposite order, basically drawing the tilemap backwards, so we're decreasing VC instead of increasing it like last time, but everything else is basically the same. Now in this case, the only difference is the source pattern data we're using, because we pre-flipped all of that bitmap data. So all we need to do is effectively add 256 to the Y position of the source pattern data we're using, and you can see we are doing that just here. We're incrementing the H part of our VRAM source here before we load it here. So we're just basically incrementing the H part, which is effectively adding 256 to the line number here. So that is calculating the flipped source pattern data, and of course it was the transferring of the pattern data that did the actual job of X flipping. And so in both cases we are actually using the same fast copy command here. It's not the copy command doing the flipping, it's the source data has been pre-flipped. So that's how we're doing our X flip. Now I'm working on a version of this, a successor to this I should say, called Mintile, which is going to be the version that allows for X flip, Y flip and XY flip, as well as some other things. So this is really just a simple example. Now you can go to my website, download the source code, the build script, and as I would say, you're welcome to use this example. You take the code apart, use anything you can, and if you can use nothing, make it all better. You're welcome to do that. You don't need to even give me credit if you use it in a commercial project. Thanks for watching today, and goodbye.